Hi, welcome to the Calculus 3 assignment practice series. And we are in the unit of partial derivatives. And this is our assignment number 7. And we talk about the maxima and the minima values. And so we're going to practice a few problems from the assignments number 7 worksheets here. Okay, so now let's go to the worksheets here. And okay, so then let's start. The first pages of the problems, they are very mechanical type of problem. I want you to find whether they have a maximum value, local max, local mean, and the saddle point. So basically, you just plug the number into the d's, right? The d is equal to the f of xx times f of yy minus f of xy squared. And then you use the criteria to decide. Okay, so now the first problem, and I like to work is to find the kind of refresh our memory about how do I find the absolute max and the absolute mean value, for the f of a set D, and this D is closed. Okay, so it's a closed set here. Okay, so now for this problem here, we said f of x squared plus y squared minus 2x, and D is a closed triangle regions here. So let's draw which area I'm looking for. So this is 1, 2, and this is 1, 2, 1, 2. So this triangle have vertices is 2, 0, 0, 2, and here. All right. So those are my triangles here. Okay, so like in here, when we talk about here, so the first things here, when we do that, just like we did in the calculus 1, the first, let's try to find inside these regions, right? So inside this region, where could be the max and the mean? So we use the critical point concept to find in here to see if we have any local mean, local max inside this region. Excuse me. So now the first, let's take a look at the partial derivative. So the first derivative, so the fx is 2x minus 2. We will set it equal to 0. The same way we set the f of y is 2y is equal to 0. So what do we have here? We have x equal to 1 and the y equal to what? And the y equal to and the y is equal to 0 here. So we have our critical point. So we have our first critical point at 1, 0. Okay, so then you plug in the f of the 1, 0 to see what you have here. So you will have a -1 here, right? So at the same time, let's try to create a table to kind of the recording what we have. So the first one here, this is x, y. So I have 1, 0, and this is f of x, y. So what is this? Okay, so what is the f of x, y? So 1, 0, this is our critical point, right? And I have this -1. Okay, so now let's go to the each lines here. So the first one, now after that, I need to go through all the boundaries, right? So this is my first boundaries here. Let's call this line 1 here, okay? So now I need to find for the line 1 here, right? So line 1, this is the one, is x equal to 0, correct? And then we have f of the 0y is equal to the y squared. So that is the y squared. So what is the y? Is from -2 to +2, correct? Okay, so now we take the derivative of this is become some function of the gy just by itself is y squared. So we take the first derivative is equal to the 2y and we set it equal to 0. So the Now we have the y equal to 0, right? So y equal to 0 and x equal to 0. So I have 0, zeros here is what is the value is 0, right? So this will be the one critical points. And now I'm looking for the two endpoint, right? Because I need to cover the whole lines here, the whole boundaries here. So the first point here, right? So I have the y, I have a 0 and the 2. So when the 0 and the 2, I have a what? I have a 0 and the 2, I have a 4. Now also I have a 0 and a what? Negative 2. I also have a what? I also have a force here, right? So I know when the here, this is 0, 0, right? So when the 0, 0, I have a 0. This is because of the line 1, right? Those is the minimum value on the line 1. And then I have a 0, negative 2, also is a line 1, and the 0, 2 also is a line 1, right? So this is the max on the line 1, right? So now I put here, so what is the value here? It's 4 and 4, right? Okay, so now we'll finish the first line, then let's take a look at the second line. This is my second lines here, right? So this lines here, I call this is L2. Okay, so for L2's here, okay, so L2, this line, the equation for this line is what? This one's here, this is y equal to the x minus 2, right? So this is the equation for the lines here. And so we can say that we plug in, so the x, then the y is x minus 2, correct? Okay, so then you plug back in what you have here. So it's x squared plus x minus 2 the square minus 2 the x. And of course, your x here is the value of the x, right? So it's 0 to 2. So if you simplify this, you will get this one is 2x squared minus 6x plus 4. Okay, now this will be some function of the hx functions here. So this is 2x squared minus 6x plus 4. Okay, take the first derivative. Okay, so you take the first derivative. Okay, so the first derivative is here. Okay, so the first derivative will be h prime x equal to the 2x minus 6, correct? And then you will, so this is a 2x minus, oh no, so it's 4, the derivative is 4x minus 6, so will be equal to 0. So what is my x here? X equal to the 3 over 2. Okay, you plug in the x equal to the 3 over 2. So x is 3 over 2. So y is equal to the x minus 2, right? So it's 3 over 2 minus 2. Y is equal to negative 1/2. So you will have the first point. So this will be what? 3/2 and negative 1/2. That's the critical point on this lines here. So you plug this number into the function and you will get a negative 1/2 here. So let's continue adding the point here. So this is 3/2, this is negative 1/2. This point is happen on the L2. And what is the value you have? You will go to negative 1, 0. And then you need to look for the end point. So this end point here is 0 to the negative 2, we already covered. So we need to cover this point. This is 2 zeros here, right? Okay, so we know the 0 is 2. So now here, let's take a look at the f of x, 2, 0. What is this number, this point here? 2, 0 is 0 also. So this one's here, you will say, here you have 2, 0. Then this happens L2, this one will be 0. So for this one, 0, -2, so you can add here, so will be the L2 and the L1s, right? Okay, so now the last ones here, let's take a look. We have what? We have this ones, right? Okay, so we have this side and this one we call this the what? L3s here. Like I say, it's like very tedious. You need to go through each boundaries, right? Okay, so now the L3. Okay, so let's take a look at L3. L3 is y equal to the 2 minus x. This is our line. So then my xy will be the 2 minus x. Then you plug in into the function. So it will be x squared plus 2 minus x squared minus 2x. So if you simplify it so if you simplify that, and you will get this one. Also, I combined that, this one. So this is 2 minus x squared, right? So I have this is 2, and this one's here is, I think, hold on, this one, I see that if you combined it. Okay, so this one's here. So it's, when you combine it, it will be the same things like we had before. So this will be the 2x squared minus 6x plus 4. So here's plus 4. Okay, so then we take the derivatives, right? So, okay, so then we take the derivative. So when the x equal to, okay, so we take the derivative of here. Okay, so let's call this is some type of the function f of x. H of x here is equal to the 2x squared minus 6x plus 4. So h prime x equal to the 4x minus 6 equal to 0. So I will have x equal to the 3/2. Then you plug in y equal to the 2 minus 3/2, right? So it's 1/2. So I have another point here. It will be the 3/2 and the 1/2, right? Okay, now let's take a look at f of the 3/2 and the 1/2. So this one still will give you the negative what? 1/2 here. Okay, so let's try to put this first point in. This is 3/2, 1/2 will give you negative 1/2 because this is on the line 3 here. Okay, on the line 3, then if you take a look, the end point for the line 3 will be, the end point for line 3 will be 2, 0. We are already here, so you can add line 3 here, and 0, 2, 0, 2, you can add the line 3 here. So we did not miss any points, right? Okay, so now you take a look at this table. So it included all the critical points and the end point, the boundary point. So what is the smallest one? This is the smallest one, right? So this is the absolute what? This is the absolute mean. Then what is the largest one? This 2 is the largest one. So I have 2 absolute max here, all right? So that's why you can conclude for these ones here, at the critical point 1, 0, you will have what? Absolute minima is equal to what is -1. Then you add the 0 plus minus 2. At this 2 point, you will have an absolute max here, okay? So this is the type of the problems, like with the boundary, and so you need to consider all the boundary, just like we did in the Calc 1, when you want to find the absolute value in the interval, so you need to substitute the 2 endpoints, right? Okay, so the next problem we're going to take a look is kind of the remaining problems. We're going to take a look at all the application problems here. So let's say find the short distance from 2, 0, -3 to the plane. Okay, so the plane, so let's see the XYZ, right? So let's say the XYZ is a point on the plane. right? So the distance formulas here will be, so we know the distance formula will be x minus 2 to the square plus y square, then plus z plus 3 to the squares, right? So we want to what? We want to minimize this. I want to find the minimum value. So instead of try to take the derivative of the square roots, I know the square root. So if you square that, x plus y square plus z plus 3 square. So if you minimize this function is the same, you minimize d square is the same thing like you minimize the d's here, right? Okay, so now you also we call this is, okay, so now we also know the x plus y plus z equal to 1. So I know the z is equal to the 1 minus x, 1 minus y. So I can rewrite this one, say the distance square is equal to the x minus 2 square plus y minus y square, then plus z is 1 minus x minus 1, right? Plus 3 square. So this one you can write this is x minus 2 square plus y square plus 4 minus x minus y squares, right? Okay, now you can call this is f of xy. After you set up the problem, then the remaining will be the same, right? So you set the first derivative. So the first derivative is, okay, so it will be 2 to the x minus 2 plus 2 to the 4 minus x minus y chain rule, right? So you can simplify that. You can better. There will be 4x plus 2y minus 12. Okay, you set it equal to 0. Then f of the y, you take the derivative of this one, it will be the 2y plus 2, 4 minus x minus y, and then chain rule is negative 1. So you combine it, you can get 2x plus 4y minus 8 equal to 0. Then you solve the system linear equations for these two. Those are the linear equations, so it's easy to solve, right? So after I solve it, I find that the x equal to 8 over 3, and the y is equal to 2/3. Okay, so this is my critical point, right? So my critical point here is equal to the A3 and the 2/3. Okay, so now, now I'm doing the f of x, f of y, right? So then the f of xx here, it will be what? It's 4, right? You take the derivative of this one. Now, what is the f of yy? You take the derivative of this one is 4. Okay, so yy, so it's take this one, so will be 4. Now, what is f of xy here? So the f of xy, that means in here you take the derivative of y, so it's 2. Okay, so now I know my d is 4 times 4 minus 2 to the square. So it's equal to 16 minus 4 is 12, is greater than 0. And both of them is positive. That means both of them open up, right? So open up, you will have what? You will have a minimum values here, okay? So that's why we say these ones here, because it's both open up here, so I know the shortest distance, the absolute mean is at what? So the absolute distance is at the a over 3 and the 2 over 3. And the distance is, what is the distance? You just plug in these numbers, right? So you plug in x is a over 3 minus 2 plus 2/3 square, then plus 1 minus 4 minus x, so a over 3 minus y. Minus y, what is y? 2/3 square. So you calculate that, and so the final answer is 2 over square root of the 3 here. So the shortest distance is 2 over square root of the 3. Okay, so the last is just like calculus 1, you need to set it up. After you set it up, then the solving is pretty easy here. Okay, let's try to do a couple more. Okay, so the number 44 is here. We say find 3 positive number and whose sum is 12 and the sum of the square is as small as possible. Okay, so I know x plus y plus z, this will be equal to 12, right? Okay, now the sum of the square, so I know this one's here, the z is equal to the 12 minus x minus y here, right? So the sum of the square will be the small, so it's x squared plus y squared will be z squared. This we want to minimize it, right? So this will be x squared plus y squared plus z squared is 12 minus x minus y to the square. I can call that this is f of xy. I want to what? I want to minimize, right? Okay, so when you want to minimize, so what you do? We do the partial derivatives, right? So f of x, so this is the 2x plus 2, 12 minus x minus y, chain rule equal to 0, correct? Okay, and then this one's here, the f of y is 2y plus 2, 12 minus x minus y minus 1 equal to 0 here, right? Okay, so now this one's here, this will be the, so the, like if you solve the system of the equations here, so this is pretty easy to solve also because they are linear and 2 variables. And so you can try to solve it and you find x equal to 4, y equal to 4. So I know my critical point is 4, 4. Okay, so if you simplify this a little bit, this f of x is going to be the 4x plus 2y minus 24, right? Then f of the y is equal to the, f of the y is equal to the 4y plus 2x minus 24. All right, okay, so the, now, okay, so now you want to find the f of xx, the double derivative. So this is 4, and the yy is here. So what is this one's here? Yy is 4 here. What is xy is here? Xy is 2. Okay, so the d is fxx, so it's xxyy minus f of xy to the square. So it's 16 minus 4, so it's 12 greater than 0. So again, right, so this is the, you know, so this is both concave up. So concave up, you have minimum value. So I know the 4, 4 will give the minimum values, right? So minimum value of the sum. So that means, so x equal to 4, y equal to 4, z is equal to the 12 minus x minus y. So z equal to 4. So the 3 positive numbers. So what are the 3 positive numbers? You're going to find this here is a 4, 4, and 4. So these 3 that add up is equal to 12, but they will give you the smallest numbers here. Okay, now let's try to do one more, and I think we have a pretty good idea how to do this one. So let's take a look at number 48 here. So the number 48, it says find the dimensions of the rectangular box, the largest volume, if the total surface area is given at 64. Okay, so here, that means I have a rectangular box here, right? So we say this is x, y, and z. So I want to find the largest volume. That means I want to maximize it if the total surface is 64. Okay, so now let's try to start here. So the surface area So the surface area will be the 2xy plus yz plus xz's, right? So because your x times z, that will be the areas here, right? And now you want to do what? You want to simplify this. So this one is equal to the 64. The volume is x times y times z. You want to maximize this one. Okay, so for here, now I need to change it to this to a fxy function. So I need to solve for z. So I have xy plus yz plus xz equal to 32. All right, so this one's here. I have y plus x factored z out is equal to the 32 minus xy. So what is my z's here? Z is x plus y and what? 32 minus xy, right? So now my volume I can say is x times y times x plus y. Then this is 32 minus xy. Okay, so I want to what? I want to maximize these ones, right? So let's see here. Okay, so we do the same things, f of x here, right? So f of x, this will be, you need to use the quotient, you need to use the product rule and the quotient rules. And so I already did this, so this one will be x plus y. So you can verify to see you get the same derivative or not. And this is the y square. And here, this is 32 minus 2xy minus x squared. Okay, so you can verify it by using your calculus skill. Then the f of the y is the same thing, and use the quotient rules here. So f of the y, this is x plus y, this is the square. Then here you have x squared, and then times 32 minus 2xy minus y squared. Like I said, you can double check. Then you set this one equal to 0, this one equal to 0, all right? And then solve for that. So you solve for this systems, right? So after I solve it, I find this one here is what? I find that the x is equal to 8 over square root of the 6, and the y also equal to the 8 of the square root of the 6 here. And then you plug these two to the z functions, right? So the z will also become a of the square root of the 6 here. So after you find this, you know this is your critical point, and then now you will be able to do the same things. And then you will say that you find the f of x, and so here you need to use the quotient rule again, and then also you find the f of the y, then also you find the f of xy. Then you substitute. So basically, then you have d is equal to the f of xx, a over square root of the 6, a over square root of the 6, and the times the y, the a over square root of the 6, the a over square root of the 6, right? And then minus f of xy, a over square root of the 6, a over square root of the 6, and square that. And you will find this is your d value, and your d value is greater than 0. And then, right, so you can find that this is greater than 0. And that's why also you can check f of xx, right, is less than 0 when you plug this point in. So that's why you have the max. So after that, so the hardest one is you set it up. After you set it up, and then you take the derivative. Like for this problem, derivative is not that simple, right? So you need to be careful about how to solve it, all right? All right, that's it. That's it for this assignment. And for here, I did not finish that, but the remaining will just be very tedious algebra job. You just plug in your critical point in there, then figure out what is the values. All right, that's it. And I hope the the few problems we did here can help you to understand and these topics here, how to find the local max, local mean, and how to find the absolute max, absolute mean, the critical values, saddle point, those things in R3. All right. Okay, that's it. And you have a good day. Bye.